Hello dear grade 9 students. In these videos, we are going to make training exercises about algebraic expressions. And here we go with the first training exercise. So as you see, it is a complete exercise having so many ideas that you are going to see, and that will make you so confident in solving algebraic expressions, in factorizing, expanding, finding domain of definitions, and so on. Here we start with a of x that's equal to x minus 1 into x squared plus 2x plus 1. And here is b of x that's equal to x cubed minus 2x squared minus x plus 2. The first part, we have to factorize each of a of x and b of x. In the second part, we have to solve a of x equals b of x. So we have to find x when a of x equals to b of x. In part C, we have this rational form. We have to find the values of x where this h of x is defined, and then to simplify it, we have to solve h of x equals 2 over 3. And finally, we have to evaluate h of radical 3 and to rationalize its denominator and to write it in the form of a plus b radical 3. Are you ready? Let's go. So to factorize a of x, first of all, we think of taking common factor. Is there any common factor to take? No. So we start thinking of identities. X minus 1 is kept as it is, while x squared plus 2x plus 1 is definitely the identity that's equal to x plus 1 squared. So that's the factorized form of a of x. It's just x minus 1 into x plus 1 squared. Now, what about b of x? B of x is grouped, as you see here. It was x cubed minus 2x squared. It was x cubed minus 2x squared minus x and plus 2. So all what we did is that we took these together and these together, and definitely we are going to change the sign inside because here we have minus, and again if you are going to expand, then you are going to get minus x and the plus 2 again. So that's why we have x cubed minus 2x squared in the first group and x minus 2 in the second group, and they are separated by the minus sign. Now we take x squared as a common factor between these two. So x squared is outside and what remains inside is x minus 2, and this is kept x minus 2. Now we can notice that the common factor among these two is x minus 2. So we take x minus 2 outside. What remains from the first one is x squared, and the one that's outside is replaced by 1. So we get x minus 2 outside into x squared minus 1. Thus, when factorizing this one, we're going to get x minus 2 into x minus 1 into x plus 1. And by this, we factorized b of x. So the factorized form of a of x is x minus 1 into x plus 1 squared, and that of b of x is x minus 2, x minus 1, x plus 1. We say that b of x is written as a product of three factors. Now, how to solve a of x equals b of x? So all what we have to do is to take the factorized form of a of x equal to that of b of x. Now we take all of this package to the other side. So as you see, it's like a single package. So we hold it to the other side and we put a minus between them. Then we search for the common factor among these two packages. This is the first package and this is the second package. So the commons are two factors as well. They are x minus 1 and x plus 1. So we take the common factors x minus 1 and x plus 1. So we open a square bracket. What remains from the first one is just x plus 1 minus in the middle, and what remains in the second one is x minus 2. Now we introduce the minus sign, so we are going to get x minus 1 outside into x plus 1 into x plus 1 minus x plus 2. Now this x will cancel this x because they are opposites. So what remains is 3. Here remains 3. Thus, the final factorized form is 3 into x minus 1 into x plus 1, and then don't forget equals to 0. Now we don't look at 3, we don't consider it because it doesn't have a variable with it. We just take x minus 1 equals to 0, means x equals to 1, or x plus 1 equals to 0, which means that x equals minus 1. And thus, 1 and minus 1 are the solutions of a of x equal to b of x. These are the solutions of this equation. So as you see, first of all, we take the package in the right to the left side. We put instead equal to 0. We start factorizing, and after we factorize, and after we get factors, we start solving each one alone. We start taking each one equal to 0 alone, one by one. And finally, we are going to talk about h of x now. H of x is equal to a of x over b of x. So definitely we are going to take the factorized form in order to make things easier. So a of x, which is x minus 1, x plus 1 squared over the factorized b of x, which is x minus 2, x minus 1, and x plus 1. Now we notice that we can simplify x minus 1 with x minus 1 and x plus 1 squared with x plus 1, but before that, we have to maintain the domain of definition. So that's why they ask us usually to find the domain of definition and then to simplify in order to maintain the domain of definition. To maintain the domain of definition, we just look at the denominator of this rational form. The denominator consists of 3 factors, so I have to maintain that 3 factors should not be equal to 0 one by one. So I start with the first one. X minus 2 should not be 0. Then, definitely, x should not be 2. That's obvious. X minus 1 should not be 0. Then, obviously, x should not be equal to 1. And x plus 1 as well should not be 0. Then, x should not be minus 1. Thus, the domain of definition of this rational form is all the real numbers, all the set R, except, this minus means except, the excluded values, the rejected values that make the denominator 0 are 2, 1, and minus 1. These are rejected because they make the denominator 0. If I substitute 2 here, I'm going to get 0 times the others, then the 0. If I evaluate 1 here, I'm going to get this 0, and then the others are 0 because it's a product. And if I evaluate minus 1 here, I'm going to get this one 0, and as well their product is 0. So I'm excluding the values that make the denominator 0. After that, I can simplify x plus 1 by x plus 1 and remains x plus 1 in the numerator. And I can get rid of x minus 1 and x minus 1 by simplifying them. And definitely I'm going to get that h of x equals x plus 1 over x minus 2. So that's about the domain of definition and simplifying the rational form h of x. Let's see what we have also. We have to solve, after simplifying h of x, we have to solve h of x equals 2 over 3. Now, to solve this, we take the simplified form of h of x, which is x plus 1 over x minus 2, which is equal as required to 2 over 3. All what we do is to cross multiply. We make this cross multiplication method. Then we multiply 2 by x minus 2 and 3 by x plus 1. Then 2x minus 4 equals 3x plus 3. So 2x minus 3x, take 3x to this side, and take minus 4 to this side, then we are going to get 2x minus 3x in the left equals 4 plus 3 in the right. Then minus x is 7, so x is minus 7, and I wrote here accepted. Who can tell me why? Guess why I write accepted? Because the domain of definition is R except. three values that are 2, 1, and -1. So the only values that are rejected for x are 2, 1, and -1. And since -7 is not among these values, that's why we say that -7 is accepted. But for example, if I get 2 or 1 or -1, one of these values that are rejected, I have to say that this x is rejected, and thus this equation has no solution if the value is rejected. And finally, we have to evaluate h of radical 3. So again, we evaluate in the simplified form. So in x plus 1 over x minus 2, x is replaced by radical 3, then we are going to get radical 3 plus 1 over radical 3 minus 2. Whenever we see a radical in the denominator, we have to think of rationalizing it. So to rationalize the denominator, we just multiply up and down by the conjugate of it. The denominator is radical 3 minus 2, then the conjugate is radical 3 plus 2. Start expanding, we'll get 3 plus 2 radical 3 plus radical 3 plus 2. While in the denominator, all what I have to do is squaring of the first one, applying the identity of a squared minus b squared, minus squaring of the second one, then I'm going to get 3 minus 4, which is -1. So I have 5 plus 3 radical 3 in the numerator. 3 and 2 is 5, 2 radical 3 and 1 radical 3 is 3 radical 3, and -1 in the denominator. So I can push that minus to the numerator to get -5 minus 3 radical 3 and without a denominator. The required is to write it in the form of a plus b radical 3, and pay attention to that important idea. It's taking us back to radicals, to real numbers. So to maintain a, we have to look at the number that's not carrying or that's not having a radical beside it. It is -5, so we take it with its sign. And plus b radical 3, then b is this -3. So a is -5 and b is -3. And by this, we are done with the first training exercise about algebraic expressions. In the coming videos, we are going to solve more training important exercises and hope you are going to enjoy the other videos as well.